What is the change in entropy of the surroundings when 2 mole of carbon disulfide are combusted at 6 degrees Celsius? So you've given the reactions and the change in entropy of formations. So please pause now the video and calculate the change in entropy of the surroundings, please. So to compute the total change of entropy of formation, we use Hess law. So we have given the reaction here. So in the first step, we calculate the CO2. You see 1 carbon plus oxygen reacts to carbon dioxide, and the change in entropy of formation is minus 393.5 kilojoules per mole. In the second step, we calculate sulfur dioxide. And you see there are 2 moles of sulfur dioxide. So we have to multiply everything times 2. So 2 moles of sulfur plus 2 moles of oxygen next to 2 moles of sulfur dioxide. Therefore, we have also double the change in entropy of formation, which is now 2 times minus 296.8 kilojoules per mole. In the last step, we have to do the reaction from carbon disulfide to carbon and to mole of sulfur. Because there we had the entropy of reaction of the inverse reaction, we have to put a minus sign for the change in entropy of formation here. So it's minus 87.9 kilojoules per mole. So if we add everything together, we get a total change in entropy of formation of minus 1075 kilojoules per mole. So we now calculate the change in entropy to combust 2 moles of carbon disulfide. So we have to calculate the change in entropy, which is the change in entropy of formation times the number of moles. So we have minus 1075 kilojoules per moles was our total change in entropy, and we have 2 moles. So we have a total change in entropy of minus 2150 kilojoules. To compute now the change in entropy of the surroundings, we can use the equation which is negative, the change in entropy divided by the temperature of the surroundings. So because both negative signs we cancel out, we get the positive number of 7.7 kilojoules per Kelvin, which is very high for change in entropy.